Okay, let's get started. Today we're going to go over lectures number 2 and lectures number 3. So you can see my fingers, 2 and 3, visual aids. This is Software Engineering 2. If you've made it to the right place, we're starting at 2, not 3. So we're going to get a bunch of people who are going to come in here in about another hour from now thinking that this is when the time starts. But we've changed it to 2 p.m. You guys all know. So I'm preaching to the choir because you guys already know because you're here. Anyway, so today, although this is Software Engineering 2, we're going to talk about 2 completely different topics. Well, they're related, and it's part of Software Engineering 2. I'm going to talk about the business aspect of software engineering, and I'm going to talk about project management as a software engineering discipline. 2 very important components of software engineering. So in Software Engineering 1, we talked about everything related to software development life cycles and talked about how to build software. You should already know how to go through a development cycle. You should already know how to go through a lot of the different methodologies and stuff. So in number 2, Software Engineering 2, we're focusing on specific aspects of engineering, specific aspects of software development. One of them, the most important, I would almost have to say, has to be the business aspect. Wouldn't you think? Because what are we in business to do? Make money. So why are we going to do software development? So we can make money at it. So we actually have to know something about how to do that. Would you do me a favor and shut that door? Could you shut the door that leads into here? It leads way too much background noise. Thank you. All right, so high-level decision making. We have a lot of considerations. One of the first things we start out doing is following some sort of methodology. And basically that was the focus of the previous class, going into a waterfall model, spiral model, iterative development, all of these different approaches. All their strategies, and they're for decision making. And hopefully they produce documentation after each one of our steps, after we go ahead and gather requirements. We have a requirements documentation, we have requirement specs, and then we turn that into and we do some analysis, we turn it into a design document, and then we take that and we have a test plan, and we have all this other stuff to make sure the software is developed properly, it's verified, it's validated. But what do we do with it after that? And are we, why are we making this software anyway? And so if you don't think about the business component of it, you're kind of wasting your time. It doesn't really matter what you do on your computer. If you can't sell it, there's no reason to make it, essentially. So that's really a big decision. And so part of the big software projects, they are strategies. There's an importance for the organization, hopefully. And not all software development happens for profit. Not everybody works in a development company, startup company. Sometimes you're within an organization, you're working for a company, and you have a software development team. And the software development team is an in-house company, well, company slash department slash team, maybe 5, 6 people. You all have different roles on the team. Some people are business analysts. Some people are, strategic people. Some people, are basically programmers. You all play a different role, just like you do in a software team for a development company. And so you have management, usually senior management, that has a duty to understand the strategic decisions, the cost options, the risks. Sometimes you build in-house. Sometimes you have it outsourced. Sometimes you hire a team to do it. Sometimes you're a small company, or sometimes you're a large company and you don't actually have a software development team. That's not part of what you guys do. You're a banking organization or something. Why would you have software developers on staff? That doesn't make any sense. So usually there's senior, it's usually a higher level management that strategizes these particular projects. Lower level people, usually middle managers, come to the higher end people in some kind of a corporate meeting or setting and say, hey, you know what, we really need a customer information system or something, or we really need CRM or something, and all of a sudden then it becomes the senior guy's going to take the credit for it. All of a sudden he's going, hey, you know what, we need a CRM system, after everyone's been yelling at him for a couple months. So it's his idea, it's his decision, ultimately, and a lot of the lower end people may actually suggest it, but he's the individual who's going to be familiar with both the strategic business aspects, hopefully, and the computing aspects, and the business needs and things like that. We also, in the business aspect, talking about business today, we have this Chief Information Officer not every organization actually has one. In fact, if the organization doesn't have an IT or an IS department, they're not going to have a CIO either. And because this person is basically the head of that department or those departments. Sometimes you see two different departments. Sometimes you see IT, IS, and you're wondering, well, does that do software engineering? Well, that's what you're making the software for. So now you never really have. In most companies, within the large organization, you don't normally have a software engineering department. That doesn't exist. But you'll have IT, you'll have IS, you'll have business strategies departments. And those are the ones who are coming up with a strategy plan. And if you're going to be developing the software in-house, then you have a development team. And that development team usually works on multiple different projects simultaneously throughout the life of their career at that company. And the Chief Information Officer, he's the senior person in the organization that's responsible for the technology. So he's the one who's designing the strategy plans. Usually that person doesn't do anything and may not actually have a technology background. It's a business person. Going back to our theme for today, it's all about business. So there's a little technology in there, but it does not require detailed technical expertise. So if you are a software engineer with 25, 30 years of development experience and you get turned down for the CIO job, that's the reason why. The more experience you have working hands-on, the less you're going to really qualify for a CIO position. However, if you're a strong MBA kind of person who likes technology, who's not afraid of it, who embraces it, and you're up to date on it, then you're a good candidate. So there's something for everybody out there essentially. Depends on what you like to do. This guy is usually a vice president level. He's usually pretty high up. Most organizations these days, from a traditional sense, we always think of the CEO, Chief Executive Officer, the biggest guy in the world. Well, we also have a CTO, a CIO, a CFO, see everything these days. And he's just the information guy who's a vice president level. He's not the president of the organization, but it's as pretty high as you can get. So if you go to an interview and they say, well, where do you see yourself in 5 years? I want to be CIO. Or I want to be the chief engineering, something or other, then they, oh, you're way ambitious. At least they don't think, I want to sweep the floors in the bathroom. Don't answer that way because they don't like that. Other job titles might be chief technology. Sometimes you see CTO, chief technology officer. Background is a combination of technology and management. And you may also be working as a consultant. In fact, you may have worked as a consultant, probably internal consulting. There are very few companies that would actually consult to have a CTO or CIO do work for the company as a consultant, because this person is pretty, plays a significant role, let me tell you, in the long-term planning. So, and it is a long-term planning decision. Most of the business stuff I'm going to be going over here with is 1 or 2 year planning projects. You can't bring temporary people in for that, which is why a lot of these guys are hired inside and they're not contracted. They don't contract in. The second lecture that I'm going to go over today is all about project management. And it all starts out with the role of the project manager. Project manager wears many different hats and may be a part of the information systems, information technology, or software engineering departments, or department, one or more. Or may actually be a business person who is from any other department, marketing, sales. And the project manager, essentially, if you think about it, is going to be in charge of the entire strategy, the entire project. And in terms of software engineering, we always call things projects. In fact, any company you go to, we're on this project or that project, and at any one time there's multiple projects going on. Project manager is just the head guy. It's the CIO of the project. You want to think of it that way. And this is pretty much the basic structure you get in the US in most of these companies. And the project manager sees software as a product with many different aspects, many different players in it. They're usually a project team. And the lecture I'm going to give you on project management is going to be kind of an overview. You can actually study and major in project management. You can get a master's degree. In fact, you can get certified by the project management body of knowledge, or I can't remember what it's called. Don't quote me on this, I'm not a project manager, and I don't have project management certification. but I've worked enough in the area so I can give you at least an overview of it. But long story short, it is an entirely different career path than software engineering, but it works with software engineering. So as a software engineer, you have, and some good software engineering people turn into project managers because they get forced into that role and they end up having to put on the project manager hat. And then they wonder, well, what does a project manager do? And then they figure it out, oh wow, this has nothing to do with technology. This has nothing to do with software engineering, but it is. It's like it isn't, but it is all at the same time. So the project manager, the function of it is, in terms of what does it do, what is the product doing, what are we building, why are we building it, kind of thing. What's the market for it, the sales, the packaging, the legal components. There's a lot of different parts of the job and a lot of different things to consider. We also have in-house computing departments. So this is different than, let's say, the IT, IS, software engineering. If we think about in-house computing departments, we're building our own needs. We're fulfilling our own software needs by building our own products. And we're not usually selling to outside people. Let's say we are, as a classic example of this, and I just talked about Apple earlier today because it's fresh on my mind, so it's coming up as the first example. If we are Apple and we're building iTunes, we're certainly not going to consult that out or outsource it. We're probably going to be building it, and as the top of the slide set says, in-house. And we're going to need in-house computing needs and services, a department perhaps that might be doing our iTunes development, may also be doing, if we're Microsoft, it's developing our product, our products, our applications. It's an organization in itself. And so it might be considered a centralized computing department reporting to the CIO that I previously mentioned. It might be decentralized as well, with computing distributed across the organization. So we might have it all into one, we might have it separated out. It might be based on projects. If we're Apple, we probably have an iTunes development team. We probably also have a Mac OS X development team, operating system development team, in-house computing. We also have, we're probably separated out by departments depending upon what they're working on. So we go back to that project kind of concept. It's usually divided out by project. It may also be by product or by service. And there's usually a lot of expertise that's basically part of that particular unit. So full in-house design, software development, expertise is usually needed in the department. So as a software engineer, you might be able to spend your entire career never building software. You might spend your entire career working in an in-house development firm to, I don't know, pick out colors for user interface design. Or you might spend your entire career writing algorithms. Or you might spend your entire career doing analysis of database designs or something, which is one of the most interesting things about software engineering. You can't describe it, essentially. It's everything and anything. It's like almost saying business. I work in business. That's about the equivalence of saying I work in software engineering. It doesn't necessarily, well, what do you do? You know, it's kind of the same kind of open-ended question. The expertise might be outsourced with project management in-house as well. So just because I originally started out saying in-house means that the development's happening there, the actual source code writing, the actual database designing, the architecture, I don't know if it's an embedded product, the hardware is probably not built on premises in-house. It's probably outsourced to a manufacturing facility, to a development company, to anywhere in the world, anywhere that the expertise is located. But the management is usually held in-house, hopefully. If you start taking, and this is one of the biggest problems with outsourcing, and I'll talk about that a little bit later on in this lecture, actually, you lose control. You send it out, and finally somebody else is making decisions on what's going on. So in outsourcing, in order for it to work effectively, especially in terms of software engineering development, you have to have a tight hold on what it is you're developing, and the management component is much more important to keep a close watch on and actually have in-house. Then you can't outsource that. Well, you can, but you can't do it on every project, and it doesn't always work well. Depends on what you're doing. Simple little things, yeah, you probably could outsource the management component of it as well, but more complex proprietary intellectual property that's owned by the company, you probably want to keep more of a control on it. You know, you don't want necessarily your old trade secrets all over the world. So, also you don't want everybody else using the same program you're using. Could you imagine how many versions of iTunes might be out there, you know, all doing the same thing? It's like, wait a minute, what's wrong with this picture? And then I like to quote on the bottom, even if development is contracted to consultants, software houses, etc., organizations need considerable in-house expertise to oversee the work. That's the point I was trying to make, actually, at the bottom, the last sentence on the slide. All right, so we have this term called software houses. We have houses made out of software. No. Kind of like brick houses, software houses. Oh, that was a joke. Okay. Didn't go over well. All right, so a software house is a company that creates software for other organizations. SAP, Computer Associates. I don't know if SAP is still around. Computer Associates is still around. Infosys, I think, is gone, actually. I'm not sure. Are they still around? Oh, they are still around. Oh, very good. It tells you how much I get out. All right. So the business is a mixture of consulting packages, custom software, maintenance, and education. And this is actually more popular these days than anything else. So software houses pretty much manage the entire project for you. They're not pre-packaged solutions. They're platforms, they're utilities, they're tools, they're development environments that are created to manage your project, to help you become, help you get what you need. So because large sums of money are involved, the emphasis is on the contract, the visible processes, well-defined deliverables, and acceptance tests. So as a software engineer, if you're managing one of these software houses, you're going through a methodology that's particular for your house. It's usually part of your development environment. You're following through standard procedures. There's a lot of paperwork, a lot of bureaucracy involved in it. This is where you really see actually true software engineering principles applied. You'll see it more in a software house than you will with Acme Inc., who makes software solutions. Where did you find that? Oh, you found them on the internet. They were called Acme Inc. You guys know Acme, right? Okay, it's a cartoon. Well, no, it's Bugs Bunny. Is it Bugs Bunny? They always said Acme everything. Acme. Is there really? Oh, wow. It's a cartoon word, isn't it? From Bugs Bunny, Hanna-Barbera, something like that, cartoons. Anyway, it's an old US thing where it was a joke, not a joke, but like a fun thing. Anyway, long story short, you get these companies, Acme Inc. out there on the internet, who you don't know what you're necessarily getting. There's no reputation. Sometimes there's a reputation. Sometimes they are following software development principles. Sometimes they are certified. They see CMM, capability model. They have a level. They have something going on. They have some compliance, hopefully, with something. But you don't necessarily find it with everybody. It's something you have to look up. Software houses, they're usually a little bit more reliable. Usually, I mean, not every software house is going to necessarily live up to that reputation. But the reputation or the connotation is essentially that they're a little above standard and that they're actually following something. And they have well-defined deliverables, contracts, and stuff. Because here's what happens in the real, talking about the business aspect of software development. You find these fly-by-night companies. You're a company. Let's say you're a startup company. You're in business. Maybe this is the first couple months of your business. Who knows you're going to be successful or not. You start a bunch of projects. Oops, ran out of money. Decided to go back to school. Oh, all right. Well, where's my software? Oh, you're not going to get it. Oh, okay. So you're not quite as reliable in terms of whether you're going to complete the project. And we all know software development, software engineering from the first class. We know it's not a guarantee just because you start it, you're actually going to finish it. Or it's going to be on time, within budget, all those other aspects we talked about in the first class. So software houses kind of give us a little bit more of a security, a little bit more reliability. For those of you who are talking in the back, it's hard for me to talk over you, and I hear it in the background. So if you could take them outside in the hallway, it would be better. Thank you. I'm not looking at anyone in particular. I just hear it like a buzz back there. So, all right. Thank you. Business models. And also everybody else can hear me a little bit better too. There's less interference. Next week I'm going to have a big old microphone so I can blast over you. I was trying to get a microphone for today, but it didn't work out, so I still have to yell. And we'll try to remember to yell so I drowned out the people in the back who sure are still talking. Hello? Whoever's talking, please. Okay, thanks. All right, business models. So software is tailored for specific environments. There's different business models that might be associated with it. We have different, e-business, regular business. We have lots of different environments. So software is tailored. Very large projects, very small projects, small-scale projects, applications. As an example, you wouldn't put the same amount of effort, spend the same amount of resources, or actually go out for the same type of project for a fix to something versus the implementation of a new CRM system. Or, there's different scales, so that actually has to be taken into consideration. And believe it or not, it sounds like a no-brainer. Like, why am I even saying this? Well, it's amazing what people will spend on something when it's like overkill. It's like, well, why did you go through all of that process when you probably could have had one of your IT techs do it or something, Or it wasn't that big of a project, but turns into a huge money spending project. So projects in general have to be actually kind of considered in terms of their scale. And there's a business model associated with it. There's development options as well, as you've seen on the slide, whether it's written in-house, whether it's contracted out. Believe it or not, even large software development companies don't do everything themselves. Some stuff is actually better to contract out, especially if you don't have the expertise in-house. Why do you want to hire somebody, train them, wait for them to get up to speed, when this other company does it professionally? They write MP3 encryption algorithms, or they write, they do all this stuff, and they do it quickly. Sometimes it's a little easier to outsource. And the product may be owned by supplier or the customer. Maintenance may be in-house or by the contractor as well. It's kind of like the Maytag repairman. In fact, as I mentioned in the previous class, sometimes there's more money in repairing software than there is in building it. And some people spend their entire career doing software maintenance and repair and upgrading. In fact, everyone who was around here in the area during the year 2000, which is 11 years ago, I still can't believe that. It's been 11 years, or 10 years, I should say, since the year 2000. Those people actually made a lot of money fixing date issues and formats and stuff, from the year 2000. Well, I'm not going to rehash all that stuff, but there's a lot more money in that than building brand new software these days, if you think about it. Also, what ends up happening is nobody ever thinks about maintenance. Even big software development companies, they go through the process, and we'll talk about costing, and we'll talk about budgeting software development projects in another lecture. But you spend all the time and energy building it, and then you just let it die after that. When most of the money is actually after that. Most of the money comes in maintenance, repair, and actually getting it to continue to work, even if it was working. Software is one of those interesting things. It just continues to give and give and give. As the older the software gets, the more it gives. So the more, and when I say gives, I mean it pays. Pays well, I should say. That's why you're all sitting here, I know. Because you all want to work in software engineering to one capacity or another, probably. And then we have a package with modifications. This is the greatest software invention of all time. Pre-packaged software. What do they call it? COTS? I don't know. Off-the-shelf software. There's a couple of different names for it. It's basically pre-built systems that are modified for particular customers. There's a lot of software engineering companies out there that do nothing but resell the same software package over and over and over again. Sounds like a good idea, right? Only problem is it's not so good for the customer. It's good for the person making it. I write a program once and I sell it hundreds of times over and over again. It's pre-packaged. Got module for this, module. A lot of accounting. A lot of accounting software is done that way. HR software, government, like tax-related software and stuff, because it's all doing the same thing. Every company has the same needs, right? And you just sell them the same software. Well, actually what ends up happening is you get something like trying to make something work for something it shouldn't have been designed for. You get situations where the prepackage, is every company really the same? Do they all have the same needs? Probably not. So software, you develop for general purpose. Is there such thing as general purpose? Is it too generic? Which is usually the case. And here's the trap that a lot of customers fall into, is they go with a prepackaged solution, they spend more money getting it modified over and over again than if they just went with a custom-built software package that was made for them and them alone. And they probably would have basically spent less time and money trying to get the thing working correctly. So we have, in terms of the environment and the model, we have the client, we have business considerations, legal issues also. And in terms of the client, we have licenses, packages. And here's another interesting trap of prepackaged software in terms of a model. Not a bad business model. And here's where software developers make a lot of money. So you have version 1 comes out, customer installs it, they get it modified, and it works just fine. Version 2 comes out, they can't upgrade because they don't have the standard version 1. They have modifications. So they pay once for version 1 modifications. They pay twice for version 2 because they install version 2. Then they got to go back and redo all those modifications so that they can get their system back to where it was before. And then version 3 comes out. And I don't have to go any further to tell you what the long story is. Customer doesn't like it. Not only will they give up eventually on this, the more times they pay for it, they're going to give up. It's a hassle, and they're always the last ones to get the upgrade. Everybody else has already been upgraded. They're last because, oh no, they have custom modifications. So it's not such a good idea for upgrades. It's an excellent idea for the software developer, not so good for the customer. At that point, you'll end up having to sell them a custom solution in the long run because it just doesn't work. And then if you haven't missed the slide, or if you've missed the slide, basically the source code is modified, it's for the customer specifications. Depending upon the level and the amount of modification that's needed, it could be cost effective or it could not be. So if it's just a small, minor modification that can be done over and over again with each new update, each new release, then it actually makes sense. So it's good. It depends on the situation, whether it's a good or a bad idea. In terms of the business consideration and modifications, may be, I think that should be maybe by software house, or it might be also by the in-house team. That point's basically trying to tell you that the people selling the software could be making the modification, or the team in-house or consultings or somebody else might be making the modification. That's also an issue. Because here's what happens. Because hopefully everybody in here has dabbled a little bit in software engineering. Some of you even write source code. Who documents? Well, unless you're actually told to. Unless it's part of your pay structure, you're not going to document anything. In fact, it's like trying to tell business people to not write. They like to write. They like to write everything. Engineering people, they don't like to write anything unless it means something. So you're going to, let's say you're an in-house, you work in-house, you got this software package, it comes in, and this is 1999. You have this job, you just graduated from ITU, and this is your first job. Okay, great, you made this modification, and then you left the company, you moved on to another one, you didn't document anything. So then they upgrade it, all of a sudden, what happened? Oh, it was made in-house. We didn't make that modification. It's because it's always, oh, we didn't do it. We didn't do it. One of your guys did it. One of you, it's like the network people who make it work, who tweak it, and then they're gone. It's like, well, how does that tweak work? And the tweak's gone with them. So this is when somebody's got to take responsibility for the documentation to actually kind of, well, this is the software we installed and this is what we did with it. And I'm sure we actually all experience this ourselves when we install something on the computer. We had to do something to make it work, and then all of a sudden, like years later, what did I do to make that program work? Oh, because my friend's having that same problem right now. What did I do? And you don't remember it. So unfortunately, the only solution to that is to document history, which nobody ever wants to do, which makes modifications, whether they're done in-house or not, makes it more of a challenge as well. Maintenance as well might be done in-house. It might be done from an external source. If there's a certain way of doing a backup, certain way of doing, let's say, a restructure of the data to make it more efficient, somebody does it over and over, the guy leaves. You know, it's not part of the standard software, it's not part of the procedure. That might also be an issue. And then we have legal issues, access to source code, ownership of the modifications, and then avoiding being locked in to a supplier is also another issue. You went out and you bought PeopleSoft. I don't know why I keep wanting to use that word. In fact, is PeopleSoft still in business? Are they owned by PeopleSoft? No. What's the name of the company? Oracle. Well, that makes sense. Okay. Maybe they'll do a better job with the, with the interface. So many companies get locked into vendors because they get on a platform like a PeopleSoft or SAP or something. They get locked into a system that every single module that they have to buy has to come from the same vendor, same system. And then they're restricted by their growth. They're restricted by what they can do. And then also they're restricted by what they can modify. Because the other problem doing this whole package with modifications concept as a business model is that what happens with the changes, who owns the changes, and how much source code are you going to give out? So you've decided you're going to be the best software engineering company in the world, you're going to sell the same program to everybody, write it once, sell it 2,000 times. Are you really going to give your source code away? No. So how are they going to modify your software? We're going to make it work for you. How long are you going to support it? That's another issue. So you sold this package, it's been in somebody's company for a couple years. Should they start paying you for support? Why are they paying you for something they already bought? You know, so there's a lot of legal issues, there's a lot of those little complications that come into play. So 9 times out of 10, this whole concept in this entire slide should probably be deleted. Because what you don't want to do is either develop a prepackaged or sell a prepackaged, unless you're a small company and you're selling to a small company. Small guys do this all the time because it's a little easier than having to deal with multiple programs for multiple companies. But it does create a lot of issues in terms of legality as well. A little example on the bottom, it's hard to see it kind of low on the screen. So corporate payroll systems, accounting systems, small business systems is what that says. In terms of, you know, what happens if you're using QuickBooks? Well, you're using QuickBooks Reports, and you're using QuickBooks Quicken modules for tax reporting, and you're using Quicken this and Quicken that. You can't use anything else, essentially, is what the problem is right there. And you can't grow from that. You can't take that system and turn it into your system that's going to be further down the road when you guys are bigger, as a company, if you're the customer. So. All right, so then we have the business model, the package without modifications. So you've got this excellent idea going back to your original business concept. You just graduated from IT, you're going to make your own first software engineering company, you're going to sell packaged software. Same software, give it to everybody. So instead of just giving everybody the same thing, you're making everybody now a new customized version of the same thing. Who owns it? You do, kind of, sort of. Depends on how you write up your license agreement. But then you've got package licensed in binary form. How many users are you going to let use it? How many, you know, you're going to deliver them a binary. They can't change it. They can't move it around. Not a bad solution, actually. So the packaging typically has many different options, including configuration options. This is your typical accounting software, actually. Because let's say you're a small company. You might not need all the modules. So you're really selling a binary program. You're not giving away any software. You're not making any customizations. Because in the previous slide, in order to do it with modifications, you've got issues because how are you going to modify a binary? You can't. You've got to give out some source code. Or it's got to be scripts, or you've got to create some interface for the modifications. If you get rid of the modifications completely, you give them a binary, you're not giving away anything. It solves a lot of problems for yourself, but it makes you more generic. And then you've got to build in modules. So you got a module for this, a module for that. This is actually what Oracle does. They got the Oracle database, they got the financial, it used to be called Oracle Financials, I don't know what it's called now. Developer, I think it's called the same thing, report module, e-commerce engine, web interface, all of these other packages each one of them is expensive in itself. And it costs you for this one, for this one, for that. It's an endless pit of money spending for that company, which is not a bad business model if you're Oracle. So, all right, so the packages may be self-contained applications, or they might be designed in components, as I just described a few minutes ago, and they're all put together. We do have some legal considerations. Usually there is a clear distinction, hopefully, between the package, the license from the supplier, and the application. Usually, sometimes there isn't. As an example, the database systems, mathematical packages. So here's the third option. So you can sell them a package system, which gets rid of all of your liability. Let's say you're Oracle. Let's go back to Oracle for a second. You make a database. You're making Oracle Express. I don't know, you're making the full version. How's that? And you're selling it to companies, and companies are building their applications in it. It's almost like selling a development tool. It's almost like selling Java. You don't have any responsibilities or liabilities for any applications, hopefully, made between the two. Hopefully. And so they're taking this Oracle database, they're building their customer service accounting program in it of some sort. And there's really a clear distinction between their application and your database. And then you decide, well, we like our database, but we're going to change our database. Big problem. In fact, this happens with Oracle people all the time. We've upgraded. No, can't upgrade. Can't upgrade because if we upgrade, our application isn't going to work. So if you're the customer and you are going this route and you're buying a packaged binary that you're installing, that you're building your application around as a piece of your component, then you're kind of envisioning what this guy's going to do in the future. Is Oracle always going to be NT compatible? Actually, they're not. Well, there's no more NT. So, but for a while, actually, it was kind of nice. They came out with an NT version because before, in the old days, they were only server Unix compatible. And then they went away with that. Well, NT went away, but that was actually after the fact. Which meant if you had an NT application, you're stuck. You couldn't upgrade it at one point because the Oracle version wasn't going to be upgradable. Or something changes. The year 2000 comes around. And you're stuck because you've got your application, you've got your prepackaged component that's working with it, your database. This has changed, but this can't change, and this has got a bug. Or, there's many different scenarios that actually play into that. And so again, it can work out quite well for the vendor, and it can work out quite well for the customer, but then there are some issues that are associated further down the road that, lo and behold, everybody will run into. So. Here's another business model, the embedded systems. This is actually probably the best area to get into these days. In fact, I highly recommend, and I think we're going to be teaching an embedded systems development course, hopefully, like soon. I think we tried to teach it, but there wasn't any interest in it, like a couple of semesters ago. But this is really the wave of the future. Computers are like, what, small. They fit in the size of a watch these days. And they're in a cell phone. Your Android is a complete computer system right there. So in the business model, we got hardware and we got software. There's a problem. You can't sell the hardware without the software, and vice versa. So if you're getting into the embedded software development as a business, and you've got this lovely idea for a small, single board computer that fits in the size of a mouse, because they have the all-in-one computer already, where the back of the computer is behind the monitor, and it's a touch screen. All you need is this box. So let's say you got a better idea. You're going to put it into a mouse. I don't know why. You got to sell software for it. And not only that, you have to develop your own drivers for it. And you have to develop your own interface for it. Not only that, you have to actually develop your own software development kits for it, because people have to write applications for this as well. So imagine all the work that went into building Android. So we have, well, not too much actually, because it's Java-based. Smart idea, actually. Build it around open source Java. Make it so that you can do anything you want, and just have an API that runs on top of it that puts it all together for the platform. Not a bad idea, but those are some of the things you have to think about as a software engineer if you're getting into this business. Because today's all about the business aspect of software engineering. So in the embedded environment, There's a lot more considerations above and beyond software. Now you turn into a hardware engineer. And so you actually also have to think about bundling. What are you going to bundle? What are you going to support? It's actually kind of interesting when you think about it, because there's a lot of different examples of a lot of different approaches. So some of your embedded devices, especially your smartphones, which everyone's really familiar with at this point, has plugins for Microsoft Office interfaces. You can open up Word documents, PDF files, and stuff like that. And actually it strengthens your operating system support in terms of its acceptability for the clients that are using it, adds value to it. It really is just a decision that somebody had to make. Are we going to support this? Are we going to support that? I don't know how many people actually write spreadsheets on their cell phones. I personally wouldn't want to do it. But if I were in an airport and I needed to look at an Excel spreadsheet real quick, it's really nice actually to do it on a BlackBerry or something. So, all right, what does the slide say? Product is seen by the user as hardware product. That's actually kind of an interesting perspective. Even if the software development is a major part of the cost, it's still a hardware product. When we talk about these devices, I call them smartphones. I call it a mouse, a monitor. It's all hardware, but it really isn't hardware, it's software. So this is how software engineering turns into hardware engineering, and vice versa. And it's why some people actually get into computer engineering instead of software engineering. Because if you want to work with embedded devices, it is seriously all about the hardware from the perspective of the consumer. They don't really care about the software on it. In fact, most people, not you guys, but most people out there when they get it, like the Droid phone, they don't even know what's Android. You know, they don't even know what they're buying. They just know that they can send and receive phone calls and text messages. As long as they have text messaging on there, they're set. You know, it's just like their Windows phone. And of course, Windows had to come out with their own phone because, you know, why not? Examples might also be global positioning, GPS systems, automobile engine controls. Actually, that's an interesting field to get into, and it's a lot of growth right now, actually. Think about all those hybrid cars out there. You know how computerized they are? You know, you can see like everything, you know, the gas mileage, the fuel economy, statistics about, in fact, your average automobile, the engine is all computerized. Like in the old days, you know, you could take the car, you can actually, if you were a mechanic, you could actually easily fix things. Nowadays, you hook it up, oh, there's something wrong with my car, okay, let's plug it in to the computer, run a diagnostic on it, it goes through, and the computer says, oh, it has a bad fuel pump. Oh, okay. And then the mechanic goes out and changes the fuel pump. So somebody has to write the software that goes on to the computer chips that are in that automobile, and it is a software engineering project that's hardware-based. It's embedded because it's on chips, it's not on a computer. So it's another area of software engineering in terms of another business model. That's completely different than any of the other business models that are associated with software engineering. So. Outsourcing, I don't have to tell you about that. I think everybody in here is very familiar with the concept. So the concept, I'm not going to read through the entire slide, but just in case you haven't heard of it before, is a contract with a software house to develop software for an organization. There is a roster going around if you just came in. Make sure to put your name on it. And make sure to keep the volume down in the back. You guys are being really good at that, so thank you. All right, so outsourcing, actually, believe it or not, outsourcing is not as bad as it sounds. The U.S. companies outsource to U.S. companies in the U.S. So it's not like okay, you guys are seeing it from the opposite perspective, or most of you are, because you're international students. Americans, when you say outsourcing, they go, oh, outsourcing, that's bad. And you guys have the exact opposite reaction. Because you're like, oh, that's good. They're giving it to us. Only problem is that, you know, there's many different forms of it, and I think it's the most just the most misunderstood concept around, actually. And that's probably why, in my opinion, and actually I'm not the only one who says this, it's pretty much failed miserably as a concept. And it's not quite as popular as it used to be, because there's a lot of problems associated with it. And all of the problems, in my opinion, are associated with people's misunderstanding of what it is, actually. Because in a perfect world, if people actually understood how to do it properly, there would be no problem with it, and it would work out just fine. Benefits? Well, you don't have to hire people. And in fact, it could actually be cheaper, although for most American companies, it's more expensive. So how in the world could it be more expensive to outsource it than if you're not doing it right, obviously. Could be clearly visible, no need to build in-house teams. Disadvantages, you have the same, the outsourced company might not have the same goals. They're not going to have the same goals. They're a software development company. They're programmers. They don't care. They're only going to do what they're told to do, which is the problem right there. And there might be an incentive for prolonged projects as well to build software that can be used in other projects. There might be some issues with copyright or intellectual property issues, stuff like that. Anytime you take something out of business control from the local environment and give it to somebody else, you're opening the door right there, unless you have a contract or unless you have something in place to protect the company. So I'm not going to spend the entire time talking about outsourcing, but it definitely has proposed or has presented some interesting dilemmas. And a little quote on the bottom, the organizations need considerable in-house expertise to oversee the work. That's a good statement. So, must not overestimate the expertise of the software house either. Because we all know we can actually, within about a couple hours, I could set up my own software engineering firm. All it takes is some HTML skill and a web host. Actually, just a website would do it right there. Just a $9.99 a year web hosting company. And, I don't even have to write the page myself. I can actually just buy a package to put together a website. And then I'm open for business. And I'm an expert in software engineering. And give me all of your mission-critical projects. Which, believe it or not, I hate to tell you, a lot of people do. Which, hopefully they're not getting away with it anymore. And then we have freelance software development. That's what you guys are all doing. Well, some of you might be doing freelance software development, and it's a great job for students, actually. It's a great job for consulting work. It's a great job for almost anybody who has some skills, who wants to work temporarily, who doesn't want to do a full-time job. I do freelance teaching, actually. I'm not here full-time. So you're a student. You're taking a part-time job. You're doing CPT. You're doing something where you're freelancing. And so it's a popular word used to say you're out there making money by the hour, maybe. You could be contracting yourself. So a lot of freelancers call themselves contractors. They call themselves temporary engineers. Believe it or not, I think there's more in software engineering, software development than there is in any other industry. Because this is one job that can be done remotely from anywhere in the world, actually, by anyone with enough talent or enough skill. It's not like healthcare provider. You can't do that remote. You can't fix them. You can't be a chiropractor and work on the internet. Not going to work. But you could actually take projects. And there's a couple of sites out there, not so popular anymore because too many people abuse the system. But in the old days, back when this concept first started, there were a lot of hire a programmer websites where you could actually submit a bid and get a job back. And for $100, $50, you could get an algorithm written or you could get something done, some small little project. Unfortunately, there were too many scam artists out there. There were too many, oh yeah, we'll take your money, and they gave you garbage that didn't work. Or what ended up happening is a lot of universities didn't like that. The students would post assignments out there. Here, I need to write a program that can, that does currency conversion. Like anyone can write that program. But if you're a brand new, Java 1 programmer, hey, just for $10, you can get somebody else to write it for you, right? So it got abused in a lot of different ways, so those sites aren't quite as popular as they used to be. So as the slide would say, you and a few friends create a company to develop software. You are offered a contract to write bespoke software. Well, it's a big one. So here's how freelance works. It's kind of like the American dream. Actually, could you do me a favor? Let's shut the door. We have to worry. I don't have my microphone yet. Worry about noise control in this room. We got to shut the door. Oh, that's good. Thank you. All right. You're hoping that as a freelance, you're going to become successful. This is like what a lot of actors do. You know, you want to get, this is, actually software engineering is like going to Hollywood and trying to be an actor or an actress. You know, you're hoping that you're gonna land that good job, you know, so you waitress for a while, hoping to get identified. No, actually. A lot of actors do become waitresses first because they meet a lot of people, especially if you're, this is true actually. There's a couple of famous actresses who got their first role, their first chance, their foot in the door by waitressing and waiting on like these producers. You know, they walk into the restaurant, you're pleasant, you're happy, you serve them. Oh yeah, by the way, I act. You know, and you kind of put. This is what freelance developers do, actually. In fact, I've gotten some jobs personally when I was going to school, answering ads on Craigslist. Well, before it wasn't Craigslist, it was something. It was a bulletin board concept where you'd actually dial into bulletin boards and you'd see people like posting ads. We're looking for someone to write this. So you write it and they go, oh, that's really nice. I like that. Here, write something else. Okay. And next thing you know, they're asking you to work for them full time. You know, because they like, it's like kind of a way of sampling. So a lot of freelance companies, they start out as small startups and they end up getting swooped into another company. They end up, you know, if they're good, they end up getting like noticed, hopefully. So that's one of the goals of a lot of the freelancers. Another one is to actually be independent, to do contract work. In the States, when you say contract work, they think you're going through a headhunter company, which is the case, actually. I'm not actually talking about this type of contracting, because there's that form where somebody takes a cut of what you're paying. It's kind of like going through a headhunter. You know, this guy lines you up with work, but it's, you know, not to put it into this perspective, but it's kind of like your pimp. You know what that word means? You're pimping yourself when you're going through a headhunter. Not freelancing, it's a little different. Freelancing is that you're actually doing it yourself. You're promoting it yourself. And it's easier to freelance with software engineering because everybody wants something, everybody's always hiring for something, and you see ads all over the place. And also sometimes you get it through referrals, depending upon what company you're working for and what you're doing. Anyway, long story short, there's questions you have to ask yourself, and this is why this is all the good parts about freelancing. Here's the bad parts. What ends up happening is there's a reason why the in-house programmers don't want to do something. Or there's a reason why the company can't find anyone to do it. And lo and behold, you show up on their front door and say, oh yeah, I can do it, I can do it. It's probably more work than you think it is. There's a catch to it. There's a problem with it. There's something they haven't told you about it. And it's going to take you twice as long as you actually think it's going to take. So what ends up happening is, in the long run, what could happen is you could take all the time and energy you put into it, divide it by the number of hours you put into it, and you probably could have been working for McDonald's and made more money, which is a common problem that happens. It's not like, what's that gift horse expression? It's kind of like be wary when you take on those projects. Because some of them are like accidents waiting to happen, or they're just really bad projects. So usually you have to base it on a per hour contract. You plan on the work 40 hours a week, 50 weeks a year. You earn $50,000, divide it out. But anyway, you figure out what you get. Only problem is sometimes you have to do a lot of work on your own to estimate how much the work's going to be. And usually most of the time you're not actually told up front exactly what's entailed. You usually get, oh yeah, by the way, it has to interface with the database too. What you really want is a by-hour job through a consultant or on your own. You don't want a per project. And here's a good example of why. Especially if you're freelancing, you've got your XYZ company or Acme Inc. software development term. You got salaries, benefits, rent, equipment, travel expenses, overhead expenses, computing, software licenses, to this, to that, to training, to everything else. You add it all up. And then you add up the number of hours plus minus the time it took you to find that job, minus the time it took you to market yourself and all the extra work you put in there, and you go, well, I could make that $80. That's how much profit I'm going to get at the end. So, not too good. It's all in a matter of the strategy. Harder than it sounds, actually. So, long story short. So what is it all about in terms of the software development? You must have a contract. That's what it's all about. So in Software Engineering 1, talked about software requirement specifications and how that ends up being the contract between the development team and the company that you're building your software for. In a more of a freelance environment, we get requests, proposals, statement of work. We get a lot of different labels, contracts, agreements. Usually what ends up happening is the more successful freelancers have a good template that they're using. And with experience, after they've been burned a couple of times, they know exactly how much padding to put in there for extra hours of unanticipated requirements that they weren't given up front. That, oh yeah, by the way, a week or so later that we need to do. Anyway, so what should it contain? Obviously, are you being paid by the hour, by the project? What acceptance testing is going to be done? That's another issue with freelancing. In a free economy, buyer, what is it? Consumer's always right? Or buyer's always right? Is that, no, customer is always right. So you spent 2-3 weeks, 40, 50 hours a day, or I don't know, a week working on this stuff. Oh, we don't like it. That's it. You're done. Bye-bye, go away. We don't like it. Oh, so does that mean I'm getting paid? Nope. So anyway, it's kind of like, going into business for yourself. If you don't want to deal with that, you work for somebody else, essentially. There's plenty of software engineering jobs out there. Not to discourage anyone from getting into this, but you really do have to be a business person to actually protect yourself. And there's another concept here about who owns the software. Because the first thing your client's going to want is the source code. You've spent all this time, you've written this program, and maybe it works with their proprietary board, or maybe it works with your proprietary solution to their problem. There's this right of ownership, when they pay you after you've done the work, who owns it? That actually ends up becoming a legal issue for a lot of small companies, especially who can't afford a team of attorneys. When the company says, oh, it's mine and I'm keeping it. So you're going to spend more money protecting yourself. We'll go back to this slide here. Put in legal expenses, and then you're probably in the negative at that point. May not necessarily be worth it. So who owns it? What licenses does the other party have? Can they do their own changes? Are you going to actually do the updating of that program further on, or are you going to allow them to change it? Personally, I'd allow them to change it and just give it to them at that point. But we'll see. And who provides the hardware, the software, what's required, who's making the selection on the hardware and software. Here's the interesting thing. You get people who don't know anything about software. That's why they're hiring you. And they want you to build something. They don't know anything about hardware either. You've assembled this, and it's a combination of some hardware and some software, but they didn't spec it all out. You did, and you got a board, you got some cables, and maybe you actually did like a little board, interface board, maybe to an LCD screen or maybe to a printer. I don't know, you have something that's you developed that they automatically assume they own, and maybe it's a custom fitted piece of hardware that you did. Maybe it's something that they don't, consider part of the system, but it really is part of the system. Try explaining that to somebody who has no idea what software and hardware is all about. It becomes part of a challenge to actually figure out and to basically convey the message that, hey, you have to pay extra for this, or this isn't part of the solution I'm selling you. This deserves more money. It doesn't actually work that way. I mean, people, oh yeah, just give it to me. But wait a minute. You didn't buy it. That's not yours, kind of thing. So, and when will you get your money? That's actually all caps on the bottom of that slide set. If you don't put it in the contract, the answer is never. Seriously, it is actually never. Because people, and this sounds really bad, but people in the United States are very respectful, usually, to that degree. I mean, we're all in business to make money. If you don't have to pay for something, you're not going to pay for it. Bottom line, are you going to pay what you think is reasonable to pay for it? And if you don't actually tell somebody and you don't spell it out, the assumptions always work against you, no matter who you are and where you're coming from. So, fixed and variable cost packages. So going back And if you walked in late, our theme today is the business aspect of software engineering. So I'm going through different business models for different scenarios of different environments. And the next one we're getting into here is the concept of the fixed and the variable cost. So in terms of the software package, so we have the initial development cost of the software product. We have the cost of the packaging. Packaging? Yeah, well, actually packaging these days is pretty cheap because it's all downloadable from the internet. But we still walk into Fry's and there's still boxes on the shelves. But the boxes, you know, it's just kind of ridiculous. You shake the box and there's a disc in there. It's like empty. Like, why am I buying a box with a disc in it? In the old days, like the box was heavy. You picked it up off the shelf and it had, you know, 3 volumes of books and stuff in there, and discs and packaging and manuals. Now the distribution costs are a lot less. We don't have manuals. We have PDF files we download if we get that at all. In fact, some software doesn't come with any documentation. That's extra. We don't even get we don't get anything. We just get a download that we have to pay for through our internet access. Do we have technical support costs? $15 per copy. Wow. Packaging, well, $200 per copy. I say if we're actually doing any packaging, it might get expensive. Support costs, actually, believe it or not, are pretty low these days too. Traditionally, they were pretty high because if you think about the entire economy, this is 2011, 1992 to 1993-ish, when most Americans, I think, were actually getting their, like the computer was a household compliant appliance. People were actually bringing them home. Then the support costs were terrible. In order to get anyone to use their software, you had to teach them how to use it. Even Microsoft Office, people didn't know how to do anything. Now people are so sophisticated. They teach themselves, so we don't have the same problem. Has pretty much gone away as well as like the distribution costs as well. So anyway, if you add it all up, that's what's referred to in terms of the packaging of software and its distribution. And if you look at the concept here, this is the interesting phenomena that occurs. The revenue is pretty much a diagonal from the nothing to, well, in this particular example, it's going up pretty high. Costs start out pretty high. And this is kind of the problem with a lot of startup companies. Not to bring in more negativity into this lecture, because when you guys all leave, you're going to be, all she said was bad stuff about software engineering as a business model. I'm not going to go into that business. Well, here's another reason why you might want to consider thinking really hard about your idea. If it's not a good one, you're going to go bankrupt. That's the reality. I know it sounds kind of cut and dry, but it really is. Every software engineering company thinks they got the best product on the market. They got the best idea. And then they spend months because you can't just come up with the idea and then put it out on the market instantly. Because if you do that, you already developed it. You already spent time developing, and we all know development doesn't take a night or two. It takes like months, maybe a couple years. In Software Engineering 1, we saw it took almost a year, more than a year, 2 years. That time doesn't give you any revenue. That's almost a waste of your time if you don't actually bring the software to market. Or you bring the software to market and then someone comes out with a better I was going to say mousetrap, but I don't know if you guys would understand that reference. Build a better mousetrap. Anyway, you come out with a competing product because there's competition out there, and your product might not necessarily sell. And if it doesn't sell, you're going to go bankrupt, which is like a lot of startups. That's why they call them startups. High risk, high-tech stock, because it's bad. Well, bad risk. But if you know you have a good idea, then you go for it, hopefully. And the revenue can go up pretty high because your costs stay the same. As you notice, it's a flat line, kind of a horizontal. It looks like it increases a little bit in time as the company grows. But the costs are the costs. And the revenue can go up to anything, if you think about it. Going back to that iTunes example, how much did it cost to build iTunes? Probably a lot, actually. What does it cost them today? Nothing. How much revenue do they make on it daily? It supports the entire company. In fact, it probably supports multiple companies and multiple retirements right now on that. So it's good investment, actually. It was a good project. Profit or loss. Back to our theme of the business aspect of software engineering for today. If you sell 7,500 copies, do you make a profit of $350,000? So, did you borrow money to cover the startup costs? So, actually, it's a numbers game. How much did you invest? How much did you pay? How long did it take you, going back to this slide, until you started seeing any revenue? Because at one point, your revenue is going to cross over with your costs and you're going to break even. Business knowledge tells you there's a break-even point. You may not make it to your break-even point. You might run out of cash first, which is what a lot of startup companies actually do. Or you might actually end up with the volume of sales we need to make on this product that we spent 2.5 years developing that sells for $9.95. We've got to sell millions of these suckers and we're not selling millions. Or maybe we've developed something that we spent a lot of money on, but we're selling a lot. And we don't even know why, but we're selling a lot of it. So in a lot of ways, it's a numbers game. And it's I wouldn't say like a guess and see, but there's a lot of mystery, I would say, in the software industry. It's kind of like the restaurant business. When you go to MBA school, whatever they say, the hardest business in the world is the restaurant business. It has the highest failure rate. It is actually, because people are finicky. If they don't like the food, there's a hair on their plate, they'll never come back. They don't like, well, software actually, I would almost, from my own personal opinion, have to say is very close to that. Because you can spend a lot, you don't spend as much time and money opening up that restaurant. Usually you can get it open quicker. But then you got a finicky crowd. In the software business, you got too much startup time. That's why they have startup companies. They don't actually make a product, but they're a company that's been around for a couple of years. They're a startup. They have nothing. They're not making any money for years. And then you start making money, and then you're hoping that that revenue is going to be big enough to support all that money that you stuck into it. And then what if they find out, you know what? It's not Windows 7 compatible. You're done. Or, you know what? Another company gave something out on the market for 10 cents cheaper, and everyone's buying that. So it's a high risk. Cash flow, risk. The risks on the bottom of the slide are probably the most interesting part. There might be some extra costs if the product is a year late. That's another interesting phenomena that occurs that we don't really think about, especially in the restaurant business. No one's going to beat you to market, hopefully, in the restaurant business. Maybe. Hopefully not. What if you wanted the idea for the first, scanner on the market, and you're a year late? You might as well just fold, go bankrupt at that point, because timing is actually good. And whatever, from Software Engineering 1, we learned nothing is ever on time and nothing is ever within budget. So anyway, enough said about risk. That's what you got to deal with. Another downer. So what if you sell 5,000 copies instead of 7,500 copies? Another good question. What if you increase the price? Does your revenue go up or down? Another question. That's what they don't tell you when you get a master's in software engineering. They don't tell you that you actually have to have a business background to actually make money doing software engineering. Otherwise, you can't do it. Unorthodox business models. Here we go. This is more interesting. So, shareware. We don't see very much shareware. You guys know what shareware is? Yeah. Actually, now it's turned into demoware. Back in the old days, late 80s, early 90s, shareware was very popular. Very popular. It was free. It was people who actually enjoyed programming sat in their office and did nothing but code these nice little applications with no documentation, no support, nothing, no packaging, nothing, and they put it out there and people started using it. They made the source code available, open source. Well, shareware turned into open source. Shareware was an unorthodox way of not to say unorthodox, it's not really unorthodox, but the concept is not unorthodox. In fact, it was very nice. You got it out there, and then people paid you. They donated to you. It's almost like the guy who stands on the street corner with his guitar, with a cup. Software engineers did this to say, not only to show off their talents, but to make money, because people would pay them to support the effort. We actually still, in fact, there's a AVG, antivirus, does this. Not to plug anybody, but they take donations. You can get a free copy. You can get free antivirus software if you want it. It's shareware. It's full running version. It's not demoware that runs for 30 days, then it expires with nasty messages. AVG, if you're writing it down. I see you writing it down. If you don't have antivirus software, go to AVG. Don't get the demo, get the shareware. Free. It actually says free version on it. They give it away for free. They take donations. If you want, you can actually buy it. You can register it. Their whole game is they want to collect information from users. They want to get feedback. They take donation. Originally, it was out. Originally how this all started to begin with was open source that turned into shareware. And we all know what open source software is. Well, because we're talking about the business aspect of software engineering, open source doesn't belong in my conversation because it's not a business. It's the free world, non-business version of software engineering, where people just produce. MySQL, as an example, is a really nice database that's free, that's open source. The source code's available for everybody to use and develop. And what that is a community effort for people to build it. And multiple programmers all over the world are making changes to it, fixing bugs, improving it. And actually, as an example, MySQL is one of the best database softwares out there that does everything. Well, I shouldn't say comparing it to Oracle does most of what Oracle does, but it's free. So, there might be a bug, there might be a problem with it. But long story short, it's a kind of a community effort in development. So it's software engineering, but done by a community, and it's free. You can't sell open source software. Shareware came out of that concept. It came after the open source concept. It's still around, but it's not quite as popular. And what ended up happening is people say, well, I'm going to make it, but I don't want to fail in the software world. Instead, I'm just going to give it to people free. If it's free, people will use it. And yeah, people use it. People download it, they use it. And in the meantime, you get exposure. You get market share. People like it. A lot of shareware turned into packaged software. Because all of a sudden, it went, okay, there's value to it. They got feedback from people who used it and said, well, it needs this feature, and it needs that feature. Okay, here's a new version. Shareware people didn't give out the source code. They kept it. So it's not open source. The person who's distributing it owns it. They give it out. They let people use it for free. They take donations. They take suggestions. They get bug reports. It's almost like getting free beta testers. Well, it turned into beta. Beta testing came out of that. Free evaluation software, whatever you want to call it. And it's basically a way of cutting down those operating expenses, going back to this one here. It cuts down the costs. So your costs are probably minimal at this point. It's a hobby. And then at the point in which it was sellable, then you started making money off of it. You started making it profitable. And a lot of shareware actually got turned into packaged software. In fact, Symantec started out with a lot of, I think it was called Grandview. It was an outlining program. They had a long time ago, like in the late 80s, they had a lot of shareware products that turned into packaged software that you could buy. And that back then it was like, PC connections. Well, I think it's still around, software resource. They had distribution houses. Before the internet became very popular, when they actually used to sell software in stores. So, long story short, it was a great way of cutting down on your development costs, getting free support, free testing, getting your users out there, free marketing, free everything. And it actually created a lot of good community support for your efforts, and it made it worthwhile, because what ends up happening with a lot of startups is that there's a lot of hype within the company. There's like pizza party, let's all work all night. You guys have all probably seen that movie, what was that, with the Facebook guy, what was that movie called? The Social Network, whatever. You know, they made it sound like it was a whole, like, you know, the whole house turned into the company, you know, they were there 24 hours a day. That's all you get. If you're working for a startup company, there's nothing else. I mean, what are you going to rely on? A lot of hard work? Nothing? There's no reward in that, actually, in the long run, unless you actually make money. How many of those people actually make money? So, I mean, there's an opportunity. Facebook probably could have, in fact, in the long run, I don't know if they're making as much money as they could have. If you saw the movie, you know, the whole story behind it. But long story short, it's a gamble anyway to begin with. So you might as well, with shareware, get you an opportunity not to have to go through most of that stuff, to kind of get more reward out of it, actually see your product out there and people using it. In terms of what the slide says, what is shareware? The producer writes a software package, distribution is open, but requests a fee, maybe $50, it's a donation. Users who pay the fee may get a small benefit. And no message when you start it up. There's no expiration, it works forever. And some people have received substantial revenue this way, actually. In fact, a lot of people have made a lot of good money with shareware. Because it's kind of like, you know, nonprofits. There's a lot of profitable nonprofits. That's why it says unorthodox business on the top. Relate that to nonprofits. There's my open source, which I already talked about already. And just to make a final distinction between the three concepts, there are three distinct concepts. Shareware is different than open source, which is different than demo software. Demo software I don't like, actually, because they put it out there kind of like they make it sound like it's free, but it isn't free. And what ends up happening, and talk about unorthodox business practices, you get something, you use it, you put your stuff in there, and then you're locked out until you pay them. It's kind of like bribery, you know? Like, it's kind of like some of these internet websites. You know, you get 10 days free, 15 days, and it's demo version. Well, you've already started using it. Like maybe you uploaded files to it. Maybe you did something, you know, like address book, telephone numbers, and you're actually using it. And then it's kind of rude. One day you wake up, you turn your computer on, and it's like, oh, locked out. You must give me $59.99 or you will never see your data again. Huh, jeez. And you know, it's like, what kind of free was that? But AVG is not going to do that to you. They're never going to lock you out. All right, open source, I talked about this already. Most of the open source is Linux, Apache, Linux or Apache Perl type environment. Leading market, high quality. Actually, open source is very high quality compared to what it used to be. In fact, if you have Linux, you're taking the, actually, is there a class being offered right now, Linux operating system? Or, I don't know, I heard it was canceled, but I'm not sure. Anyway, long story short, if you get into Linux, you'll find out you'll never have to buy software. You install a Linux server, you get a free desktop. Whoa, you know, Microsoft makes you pay a couple $100s for that. Actually, in some cases, the desktop is better than Microsoft. So you get free software. Everything is open source. There's open source distributions. Linux is free. You know, if you paid for anything, like you've paid for the documentation, or you've paid for the DVD that they ship it to you on, but the software itself is free. So the general model, it's a shared development environment. They give you the source code. There's usually a license, if you're not familiar with that goes along with it. It's usually called a GNU license. It's something, a piece of one of the text files that gets shipped with it. You have to keep it. If you violate open source, the open source community actually gets on your case. It's weird. You think you're on an island of your own. You download something and then oh, no one's noticed. You know? If you actually start distributing it, or you take an open source piece of software and you put it in something and sell it, bad idea, actually. Bad idea, because there's organizations out there that are looking for you, that will catch you, and the fines are pretty steep, very steep, actually. Not worth it. In fact, it kind of violates the whole open source concept. Think about it. So anyway, centralized development, distributed source code, completely open. So what you got is it's not for profit, it's non-profit. Personal exam, Python, TCP/IP. We all use TCP/IP. That's open source. That's free. Nobody has ever paid for TCP/IP. And if we didn't have open source, we wouldn't have even had TCP/IP to begin with. So think about it. That's probably open source is good. It's here to stay. Although it has gone down, not quite as popular as it used to be, because newer generations of computer people, newer generations of software engineering, computer science students, some of them forget, like, there was the grassroots to this. We didn't always have computers. Like, somebody had to develop this stuff. And so, a lot of stuff came out of open source development. So. Okay, I hear talking in the back again. Woo-hoo. Next week I'm going to have a microphone. I'm going to blow your ears out. This week I don't have it yet. I'm already starting to lose my voice. All right, notes on open source. Software must be open source, but packaging, servicing, not a profitable business. It can be a profitable business in terms of the packaging, in terms of what this slide is trying to tell you. As an example, the Red Hat. You can actually buy Red Hat versions. And what people have done is they've taken open source, packaged it with their own utilities. I still hear talking in the back. Hello. Usually if I stop talking, then people notice. That's good. All right, so you can take and use open source and package it with your software. It's not illegal as long as you point out what is open source. Include the proper licensing. Companies like Red Hat, as an example, package on proprietary software with open source, sell you a package, a bundle. Usually they're install utilities, other applications that support, make the open source easier to use. There's a lot of applications out there that are using MySQL, which is an open source environment, a database system. A lot of the LAME for MP3 conversion for a lot of those programs that you take and you convert media for your iPod stuff with. They're using these open source packages, and usually they're recognizing or giving recognition to whatever the package is using. And you have to actually be careful as a final note in how you package it, but you can do it. You can make money off of it, actually. If you go to opensource.org, you can find out a bunch of other stuff if you have an interest in it. And SourceForge is still very popular, very active, actually, growing and growing every year. Another basically spot where you can publish your open source, store it, manage it, because not only can you freely distribute it along with the source code, there's utilities out there that are free that help you manage it. In fact, they help you distribute it, and they help you get feedback from users so that you can actually grow it. And what does the important note on the bottom say? Open source software development and distribution is particularly suitable for organizations such as universities. That would be us. Who develop software for public good. So yeah, it's actually, there's a lot of different reasons, but usually for study, for education, open source becomes very obtainable. It becomes a good option for a lot of different things. So. All right, so here's just an open source, little bit of, I already told you about the GNU public license. There's a little link. These links actually work. I just tested them today, so they're very current. This is lecture number 2 if you're downloading it, and you can try out these links. So.